Hi guys, Mr. Wilkins. This is the path problem that I wanted to go over in class the other day. This first question says, Mary and Margaret were looking at a map of a running path in a local park. Which is shorter from E to F, along the two semicircles or along the larger semicircle? If one path is shorter, how much shorter is it? So the first thing we're going to look at is distance between E to F going along the semicircle. Well, it's not that difficult. It's just half a circle. So you want to think of the circumference. What would the circumference of the whole circle look like? So we figure out circumference by pi times diameter. In this case, the diameter is going to be 4, so the whole circumference would be 4 pi's. But we're only looking for half of it, so we're going to slice this in half. So the circumference of the semicircle would only be 4 pi divided by 2, which is 2 pi kilometers. Now, so this is the important information right here. That's for the larger semicircle on the top. So next we're going to compare that to the two semicircles on the bottom. For this distance, and then this distance. Well, added together, two semicircles is a whole circle, so we can look at that by putting those two circles together as one big circle. And the diameter of that circle is going to be half of 4, or 2 kilometers. So for the semicircle, the circumference of those two semicircles put together would be pi times diameter. And we know the diameter of the whole circle would be 2, so it's 2 pi's. So, is that distance shorter, which is the two shorter semicircles, or is this distance shorter? Well, they're equal, right? So neither one's shorter, they're both equal. Welcome back, class. This is the other problem that I thought was really difficult because there was a couple things going on in it. First, we have, let me read the problem. Alex, the electrician, needs 34 yards of electrical wire to complete a job. He has a coil of wiring in his workshop. The coiled up wire is 18 inches in diameter and is made up of 21 circles of wire. Will this be enough to complete his job? So the first thing we had to do is, because the coil is given in inches, we have to think about the 34 yards in terms of inches, and we do that by multiplying the yards times the number of inches in each yard, which is 36 inches, and we get 1,224 inches. So we have to decide, to 21 circles with a diameter of 18, is that going to be 1,224? Well, let's find out what one of the circles is. So the circumference of one circle would be pi times diameter. In this case, diameter is 18 inches. So the circumference of one of the circles is 18 pi inches. Well, it's hard to decide. Mrs. Wilkins made a mistake here. That's 18 pi inches. So that's one circle. Well, how much is 18 pi inches? Well, we multiply 18 times, let's just use a quick estimate of 3 for pi. Instead of 3.14 or 3.14159, let's just use 3. And 18 times 3 is same as 30 plus 24, which is 54. So 54 inches long for each coil. Well, now we have to see if 54 inches for each coil, and we got for each circle in the coil, 54 inches times 21 circles. We have to decide, will this be more than this number up here, 1,224, or will it be less? So 54 times 21, that's 1,134 inches. And because we used pi, we should all state all these as about. It's about that much. And even if we use 3.14, I think this number still's going to be less than this number. So, does he have enough coil around in his workshop? The answer would be no. Not enough coil.